All right, here's a classic statics problem wherein we're looking for the tension in member AB and the tension in member BC. Now we know from our experience, our logic, that those tensions are not going to be the same. We also know that AB is not going to support half of the 480 kilogram load, and BC the other half. They're going to support unequal components. And so what we need to do is to figure out what that proportion is. We're going to start out by doing a free body diagram of these forces. And so we're going to do force AB, and we're going to show force BC, and we're going to show the force acting downwards. First thing, let's calculate that force. 480 kilograms times 9.81 meters per second squared is going to give us 4709 newtons of force acting downwards. Now the next thing we have to do for these problems is we have to resolve those into their components. And so what I need to do is I need to figure out the horizontal component and the vertical component of force AB, and I have to figure out the horizontal component and the vertical component of force BC. This is 75 degrees, this is 12 degrees. All right, so let's do that. If I do that, I know that this component here is going to be AB cos of 75. And likewise, this one is going to be BC cos of 12. Now, I don't know what those values are yet, but I know that that's what that is going to be in relation to AB. And so I can write down now that my left acting forces equals my right acting forces. This is statics, and therefore since this is not moving, we know that all the leftward acting forces must be balanced equal and opposite by right acting forces so that this is not accelerating in either direction. And so if I write this down, I can write down that AB cos of 75 equals BC cos of 12. And since I know that some people struggle with the algebra a little bit when it's in this form, we can just use our calculators to turn this into numbers directly. And so what I get then from this expression is that 0.259 AB is equal to 0.978 BC. And that's simply just I put the cosine sign into my calculator. Let's now look at the upwards and downwards forces. Well, this is going to be AB sine of 75, and this is going to be, BC sine of 12. And so now I know if the upward forces have to equal the downward forces, up equals down, then I'm going to get an expression that looks like AB sine of 75, in this case plus now because they're both acting in the same direction, they're both acting upwards, BC sine of 12, and they have to be has to be equal to down, and therefore that they have to be together equal to 4709 newtons. Now, once again, I'm going to simplify this a little bit right down to the point 965 AB plus 0.208 BC equals 4709. Now, I can't really solve this yet because I now have an expression with two variables in it, and I can't solve that directly. So what I have to do is I have to use this, a combination of this expression and the horizontal and the vertical expressions together. And so the first thing I'm going to do, let's say we're going to solve for AB. We're going to solve for AB first. So what I'm going to use is the horizontal equation to get BC as a function of AB. And so that's pretty easy because I can just say 0.259 AB equals 0.978 BC. And if I just divide both sides by 0.978, I get that BC is equal to 0.265 AB. Now, having this alias for BC in terms of AB allows me to take that back up and plug this 0.265 AB into this expression for the vertical now, and instead of BC, I'll plug in the 0.265 AB. And so the algebra now becomes 0.965 AB plus 0.208, and now this is where I plug in the alias for BC, 0.265 AB equals 4709. And so now I get 0.965 AB plus 0.055 AB equals 4709. I get 1.02 AB equals 4709, or AB equals 4616. Now, once I've got AB, I can come right back up here to this expression, and I can find BC. And so that means that my tension BC equals 0.265 AB, and that equals 0.265 times 4616, or 1223 newtons. And so now I have AB and BC solved for that. It really requires us just to use the lefts equal rights, ups equal downs, and their trig functions to resolve these vectors.